Show that if the sum of two unit vectors is also a unit vector, then the magnitude of the difference is square root of 3. Let us begin. Here, we will begin by considering two unit vectors a cap and b cap. And we will suppose that these two unit vectors are the sides of a triangle. Now, by the triangle law of vector addition, the third side is going to be simply the sum of the two adjacent sides. So here we have the triangle ABC. So we'll suppose that the unit vectors a cap and b cap corresponds to the side AB. So let's consider AB to be representing a cap with the direction going from A to B, and b cap to be the unit vector corresponding to the side BC of the same triangle ABC. By the triangle law of vector addition, CA vector is going to be the sum of A vector and B vector. So that means this is going to be A cap plus B cap. A cap added to B cap. So this is going to be the side CA vector. Now it's given here that when we take the sum of a cap, the unit vector a cap, with the unit vector b cap, the resultant is also a unit vector. So that means a cap plus b cap, if we take its magnitude, that's equals to 1. And by definition, we know that the magnitude of a cap and the magnitude of b cap is 1 as well. So here we can see that the triangle, all the three sides have got equal magnitude, equals to 1. That means, this implies that our triangle ABC, so triangle ABC is an equilateral triangle. Here we have a equilateral triangle. Fine. Now because ABC is an equilateral triangle, it's also going to be equiangular, meaning angle BAC will be equals to angle ACB. That will be equals to ABC, and all of these three will be equals to 60 degrees. Fine. Okay. Now we need to show that the magnitude of the difference is square root of 3. That means we need to find out a cap minus b cap and need to show that the magnitude equals to square root of 3. Now how do we find out a cap minus b cap? We'll need to find out negative b cap first. So negative b cap means it's a vector which has been multiplied with negative 1. That means its direction has changed, but its magnitude remains a positive 1. Okay, let's try to draw that particular vector. So here we have extended the side BC to the left hand side, and this side is actually nothing but negative b cap. It's a vector going from point B to, let's call it C prime, but since it's in the opposite direction to that of b cap, we are using negative sign here. So now we have negative b cap. What we'll do next, we'll add a cap with negative b cap. All we have to do is join point A with point C, considering A to be the initial point and C to be the terminal point. Now, since we have already established that angle ABC, that's going to be 60 degrees, then what is the measure of angle ABC prime? Now, angle ABC prime, so that's going to be 180 degrees minus angle ABC. So that means this will be equals to 120 degrees. This will be equals to 120 degrees. Also, we know that the magnitude of a cap, which is AB, this will be exactly equals to the magnitude of BC prime. So that means we have negative b cap. That's exactly equals to 1. This tells us that triangle ABC prime is isosceles. It's an isosceles triangle, which means that angle BAC prime will be equals to BC prime A, and that will be equals to 30 degrees. So let's write it down. So that is 30 degrees, and we have BAC prime, so that's 30 degrees. And what is BAC? That's 60 degrees. Now clearly BAC is 60 degrees, BAC prime is 30 degrees, which means that CAC prime, that's 90 degrees, and that means we have a right angle triangle which is right angled at A. So that means now we can consider in the right angle triangle CAC prime, which is right angled at A, we can use the Pythagoras theorem. So that means we have the hypotenuse, which is CC prime. We square this will be equals to the adjacent side, so that's going to be AC prime squared added to the opposite, which is AC squared, square of the opposite. So this is the Pythagoras theorem. Now let's use the value here. So C prime, so this is nothing but BC added to BC prime. So we have to square it. We're only considering the magnitude here. Then we have AC prime squared added to AC squared. Okay, again from figure, what is BC? BC is nothing but magnitude of B cap added to BC prime. So that's negative B cap, its magnitude, and then we square this value. This will be equals to AC prime squared. What is AC prime squared? AC prime, so that's A cap minus B cap. We'll consider its magnitude. So we have A cap minus B cap. We consider its magnitude and then square it. Then AC, so AC is going to be this is A cap plus B cap. I made a mistake because we are taking the triangular vector addition. So here we have A cap plus B cap squared. Okay, now magnitude of B cap, that's 1. Magnitude of negative B cap, that's also 1. So 1 plus 1, square it. This will be equals to, we need to find out the magnitude of A cap minus B cap squared added to, this was already established that magnitude of A cap plus B cap is going to be 1 because A cap plus B cap is a unit vector. Now this is going to be 1. That gives us 1 plus 1, that's 2. 2 squared, that's 4. So 4 will be equals to magnitude of A cap minus B cap squared added to 1. So let's rearrange the terms. So we have magnitude of A cap minus B cap whole squared equals to 3. We'll take the square root on both sides to get magnitude of A cap minus B cap equals to square root of 3. So we have successfully showed that the magnitude of the difference of the two unit vectors, that is square root of 3. Hence proved.